All right, so guys, we're almost done. We're almost there. We have one more example after this one. All right, and again, we're still doing the exact same stuff, but the whole thing is you have to know these actual identities and not identities, but identities and your rules that comes with integration. And if you don't know those rules, then this is going to be very hard. So don't make it hard though. All right, so here, example 5 says find the general solution for this differential equation, and then the particular solution that satisfies the initial condition of y of 0 equals -2. And again, we do the same thing we've been talking about. So I'm going to start off with here, example 5. They give you the equation. Right? And then they give you the initial value. Y of 0 equals -2. And that's why I say don't use pen, because then it looks bad like that. Right? So let me change colors real quick. All right. So here, one thing that we said before is that the y's need to go on the y side, x's need to go on the x side. And so we need to make sure we do that first. That's our first step every time. So it means dx needs to be moved to the other side. So we multiply both sides by dx. But I'm also going to change this so we don't have a negative exponent. Just to do it, because it makes it look better if it's a fraction instead of a negative exponent there for this portion. So it should remind you of some maybe trig formula or something that you might have covered before, just saying. All right, so again, we take the antiderivative of both sides. And we're going to integrate each one of those individually. So first off, we know here, like we said earlier, that's going to be y. And again, remember there's a 1 there. So that's y to the 0 power. Add 1 to that, blah, blah, blah. And so go back to the last video that we did and it explains exactly what we did there. I think it was the last video. 2 videos before that, sorry. 2 videos ago. For example 3, we explained that part. All right, so we have this. We're going to integrate both of these. So integral of e to the x, is e to the x. Then for the second portion, I'm going to not do this, not actually work it out yet. I'm going to show you, okay, this is the same thing as saying we're going to move that 20 in front and deal with just this. And this should hopefully remind you of something that we've had before. Hopefully. And if it does, which it should be tangent inverse for this function right here. So we move the 20 in front, we can see that easier. And so here, we actually have y equals e to the x plus 20 tan inverse x plus c. Okay, and again, that's our general. And again, with this, it all hinges on if you know your rules, if you know the actual integration rules. If you don't know those rules, if you haven't gone back and looked at them or kept up with them, that means you're not going to do so hot. So when it comes to this on an AP test or any test at all, you're not going to do so hot. So again, that's your x and your y. So we're going to substitute that in to find our particular solution. All right, so with all these, you should remember again how to do all these. And remember here, you can go ahead and do, let's say alpha equals tan inverse of 0. You have to do tan. So where's tan equal to 0? It's at 0. So it means alpha equals 0 because at tan of 0 is where you have an answer of 0. So that's where 0 comes into play here. So you should remember these, how to do this. All right, and then here, we go ahead and work everything out. And we should get an answer of, sorry, that's negative 2 equals 1 plus 0, because 1 times 0 is 0 plus c. We subtract that, we get negative 3 equals c. And so our particular solution will be y equals e to the x plus 20 tan inverse x minus 3. Particular solution. Yay. All right, again, it's the same process over and over again. We haven't changed anything. Only thing is your rules. Know your rules. Know when it's that to that. Know what's happening here. All right. We have one more example left, and then we are done, guys. We're done.